2,4-dinitrophenylhydrazine and its importance. This is today's lesson. In this lesson, we are going to learn about 2,4-dinitrophenylhydrazine, that is Brady's reagent, and then preparation of 2,4-dinitrophenylhydrazine, importance of 2,4-dinitrophenylhydrazine, and finally reaction mechanism of 2,4-dinitrophenylhydrazine. So let's get started. The very first point is 2,4-dinitrophenylhydrazine, that is Brady's reagent. Let's look at the matter. This is a compound. Its name is diamine or diagen. Another compound, phenyl group, at 2 position nitro group, and at 4 position another nitro group. When one hydrogen atom from diamine is replaced by this group, its name is 2,4-dinitrophenyl group, which replaces hydrogen from diamine. Then this is obtained at 2 position nitro group and at 4th position another nitro group. Now its name is 2,4-dinitrophenylhydrazine, which is in short 2,4-dinitrophenylhydrazine. This is the compound which is solid at room temperature and its color is yellowish red. So 2,4-DNPH is yellowish red in color and solid at room temperature. When this compound is dissolved in a solution that contains methanol and some concentrated sulfuric acid, then this solution is known as Brady's reagent. Which is sometimes called Bock's reagent as well. So this is all about 2,4-DNP and Brady's reagent. That is, this is the compound 2,4-dinitrophenylhydrazine. When it is dissolved in methanol and some amount of concentrated sulfuric acid, then Brady's reagent is obtained. 2,4-dinitrophenylhydrazine is solid at room temperature and this is yellowish red in color. Let's move on to the next point. Now, preparation of 2,4-DNPH. Let's look at the matter. Here, hydrazine is taken and sulfuric acid. This can be step 1. Sulfuric acid donates proton. That proton combines with this nitrogen with its lone pair of electrons, and consequently this is obtained NH3 now, here plus, and here bisulfate ion, which is called hydrazine sulfate. more precisely hydrogenium bisulfate or hydrogenium hydrogen sulfate. Step 2, this hydrogenium hydrogen sulfate is treated with 2,4-dinitrochlorobenzene. At second position nitro group and at fourth position nitro group, which is 2,4-dinitrochlorobenzene. This is treated with hydrogenium hydrogen sulfate. Then this is obtained, that is H2N, NH, here phenyl group, second position nitro group, fourth position nitro group, which is 2,4-dinitrophenylhydrazine. Here byproducts are sulfuric acid and HCl. So this is the reaction by which 2,4-dinitrophenylhydrazine is prepared. Now let's see importance of this compound. Now the point is importance of 2,4-DNPH. This compound is used to detect carbonyl compounds. Let's see what compounds are carbonyl compounds. General formula of carbonyl compounds is RCOH. This is general formula of aldehyde. Here this may be alkyl group or aryl group. Then this is aldehyde. When alkyl group, aryl group, CO, here this hand is satisfied with alkyl group or aryl group, then it will be general formula of ketones. So this is a general formula of aldehydes and this is general formula of ketones. Aldehydes and ketones contain carbonyl group. This carbonyl group is detected by 2,4-DNPH. This is the importance of this compound. Now let's see how carbonyl group is detected by 2,4-DNPH. Aldehyde is taken. Suppose this is aldehyde, which is ethanol. Ethanol is treated with this compound 2,4-DNPH. In presence of acid, that is Brady's reagent contains some concentrated sulfuric acid. Here oxygen and two hydrogen atoms form water, which is byproduct in the reaction, and the rest parts are from ethanol, CH3, here H, and here nitrogen, that is new bond, carbon nitrogen bond is formed. Here NH, this compound is formed, which deposits as precipitate. Its color is yellowish orange. So this yellowish orange color of this compound, that is ethanol 2,4-dinitrophenylhydrazone. Let's write the name of this compound, that is ethanol 2,4-dinitrophenylhydrazone. Now its name is ethanol 2,4-dinitrophenylhydrazine, which is yellowish orange color that deposits as precipitate. This yellowish orange color precipitate confirms the presence of carbonyl compounds. Now let's see detection of ketone, that means carbonyl compound. Ketone. Let's consider this compound, which is propanone. It is treated with 2,4-DNPH. Here, oxygen, hydrogen, water is formed as byproduct, and another compound, this one, carbon nitrogen double bond is formed, carbon nitrogen. This is propanone 2,4-dinitrophenylhydrazine, which is yellowish orange color, and it deposits as precipitate. So this yellowish orange color precipitate of propanone 2,4-dinitrophenylhydrazine confirms the presence of carbonyl compound, that is compound containing carbonyl group. This is the importance of 2,4-dinitrophenylhydrazine that is used to detect carbonyl group of carbonyl compounds, that is carbonyl group of aldehydes and ketones. Now let's see mechanism of this reaction, that is how this compound is formed. Yellowish orange colored compound, that is carbonyl 2,4-dinitrophenylhydrazine is formed. Let's see mechanism of the reaction. Mechanism of 2,4-DNPH. Step 1. Any carbonyl compound, suppose propanone, which is protonated first, that is present in the Brady's reagent. Carbonyl group is protonated in this way. Then this is obtained. Here plus, here CH3. Now this ion at step 2 combines with 2,4-DNPH in this way. Here lone pair of electrons present over nitrogen, and in this bond, because of this positive charge, pi bonded electrons move towards oxygen. This carbon gets positively charged, and then this nitrogen forms bond with this carbon, and then this is obtained, that is CH3, here carbon, here CH3, OH, here nitrogen, hydrogen, here hydrogen, NH, here over nitrogen, positive charge. Now in this ion, because of this positive charge, these covalently bonded electrons move towards nitrogen, This hydrogen gets freed as proton that combines with oxygen. Now this is obtained CH3, here CH3, OH2 plus, OH will be OH2 then plus. Here nitrogen lone pair appears again, here hydrogen, then NH, now because of this positive charge from this ion, here heterolytic fission occurs and water is removed. Then positive charge develops over carbon. That is why this lone pair of electrons turn into bond pair here. Then this is obtained. Here CH3. Now carbon nitrogen double bond. With nitrogen, here hydrogen, and then here positive charge over nitrogen. Then this part, over nitrogen positive charge, because this lone pair of electrons of nitrogen turn into bond pair. That is why over nitrogen positive charge is developed. Now this ion converts to, in this ion over nitrogen positive charge. That is why these covalently bonded electrons move towards nitrogen and this hydrogen gets freed as proton, and ultimately this is obtained CH3, here CH3, carbon nitrogen double bond, then here nitrogen hydrogen, and this is the last part of this molecule. Here there will be nitrogen hydrogen, here nitrogen and hydrogen, then finally this is obtained, that is 2,4-dinitrophenylhydrazine. But before this it came from propanone, so its name will be propanone 2,4-dinitrophenylhydrazine. This is the compound which deposits as yellowish orange precipitate. This yellowish orange precipitate proves the presence of carbonyl compounds, that is aldehydes or ketones. 2,4-dinitrophenylhydrazine, which is used to detect carbonyl compounds through detection of carbonyl group. This is all about 2,4-dinitrophenylhydrazine and its importance. No more today. Thank you very much.